ethyl benzene when treated with KMnO4. Ethyl benzene when treated with KMnO4. So we know that if the molecule has benzylic carbon and it has benzylic hydrogen, simply we have to write down the answer benzoic acid. We should write the answer benzoic acid. The benzoic acid treated with SOCl2, and here carboxylic acid group is there. So in carboxylic group, OH group replaced by carbonyl chloride. OH group replaced by carbonyl chloride. So it is a benzoyl chloride. Benzoyl chloride. Now it is treated with dibal H, diisobutyl aluminum hydride. So minus 78 is granted. Therefore H minus attack, leaving group will leave, and finally it gives corresponding benzaldehyde. Corresponding benzaldehyde. Benzoic acid treated with benzyl alcohol. Benzoic acid treated with benzyl alcohol in the presence of H2SO4. In the presence of H2SO4. So it is clearly esterification. Acid plus alcohol in the presence of H plus, it forms carboxylic ester. Therefore, this lone pair attack on this carbon, leaving group will leave. Therefore, corresponding carboxylic ester is formed. It is a corresponding carboxylic ester. Now this carboxylic ester treated with CH3, COCl, AlCl3. So from this we have to remove AlCl4 minus, and we should write electrophile CH3CO plus. Electrophile CH3CO plus. Now here we are having two benzene rings. This benzene is deactivated because of minus R. This benzene is activated because of plus H. Therefore electrophile attack at the para position, because plus H group is OP directing group. That's why the corresponding product is at para position. We should write the corresponding acyl group. Acyl group is COCH3. Now this product is treated with NaBH4. This product is treated with NaBH4. So NaBH4 is a reducing agent, and here we are having two functional groups. One is carboxylic ester and one is ketone. So carboxylic ester cannot be reduced, but ketone will be reduced through nucleophilic addition, and finally gives corresponding product like this. Benzoic acid treated with NaOH NaOH. This is known as soda lime. It is known as soda lime. When soda lime is used, we have to think about the decarboxylation. So you have to write the decarboxylation like this: intermediate carbanion and then acidification. Benzene. So the first product is benzene. Benzene treated with ozone. Benzene treated with ozone, zinc H2O. It is reductive ozonolysis. it is reductive ozonolysis. And here only benzene is present, that's why we are taking ozonolysis for benzene, and finally it gives corresponding 3 moles of glyoxal. 3 moles of glyoxal. Now it is treated with concentrated NaOH. It is treated with concentrated NaOH. Therefore, when aldehyde react with conc NaOH, first we have to think about aldol and then think about the Kenizaro. And here no alpha sp3 carbon, that's why it undergo Kenizaro. So in the Kenizaro, OH minus attack on the aldehyde, and that aldehyde group undergo oxidation, and the remaining aldehyde group undergo reduction. So it is an example of Kenizaro reaction. Kenizaro reaction. One aldehyde undergo oxidation, another aldehyde undergo reduction. Cyclohexane carboxylic acid. Cyclohexane carboxylic acid treated with Cl2 and red phosphorus. Cl2 and red phosphorus. So this reaction is known as HVZ reaction. Hell-Volhard-Jelinski reaction. So in the HVZ reaction, the alpha proton replaced by electrophile. The alpha proton replaced by electrophile. In this case, electrophile is Cl+. In this case, electrophile is Cl+. It is an example of electrophilic substitution. It is an example of electrophilic substitution. Now it is treated with alcoholic KOH. Alcoholic KOH. So here leaving group is there and alcoholic KOH, so it prefers elimination. Since it is a strong base, so either E1CB or E2 possible. But if I write alpha beta, so E1CB condition are not present, because at beta position minus R should be there, but there is no minus R at beta position, therefore no E1CB, only possibility E2. That's why according to E2 mechanism, we get corresponding unsaturated carboxylic acid. Because of double bond, it is unsaturated carboxylic acid. Now it is treated with HBr peroxide. So HBr peroxide, from this we get Br radical, and this Br radical attack on the alkene produces stable radical. And the stable radical takes hydrogen from HBr again, and finally it gives corresponding product like this. And here if I see the overall reaction, so overall reaction means COOH, alkene, HBr, peroxide, and final product is like this. So here this carbon has 0 hydrogens and this carbon has 1 hydrogen. Therefore in the final product, Br attached to the carbon which is having more number of hydrogens. Therefore it is a anti-Markovnikov product. Anti-Markovnikov product. And one more thing, for HBr, peroxide effect is observed, but for HCl, peroxide effect is not observed, because in the overall mechanism, bond enthalpy of HCl is not supporting the free radical mechanism. With HI in the presence of peroxide, so here bond enthalpy supporting forming I radical, but I radical combining with another I radical and forming I2. I radical combined with another I radical forming I2. So because of these two regions, so HCl and HI do not show peroxide effect. HCl and HI do not show peroxide effect. HCl because of the bond enthalpy, HI because of the formation of dimerization of I radical. Carboxylic acid. It is a carboxylic acid treated with LiAlH4. After that, acidification. So here we note that it is a functional group, and this functional group will be reduced to corresponding primary alcohol. Now this primary alcohol treated with PCC, pyridinium chlorochromate. Now this primary alcohol undergo oxidation and it gives corresponding aldehyde. Now this aldehyde treated with formaldehyde and calcium hydroxide base. And here aldehyde having alpha carbon, alpha hydrogen, and here no alpha hydrogen. And that too we are using the formaldehyde. So immediately we have to remember the reaction Tollens reagent. Tollens reaction. In the Tollens reaction, first we think about the aldol addition and then we think about the crossed Kenicharo. So it is a combination of two reactions. Crossed Kenicharo. So aldol addition, alpha carbon attack, and it gives corresponding product like this. And excess of formaldehyde granted in the presence of OH minus. OH minus attack on the formaldehyde undergo oxidation, and this aldehyde undergo reduction. So it is our final product. So the last reaction is Tollens reaction. Tollens reaction is combination of aldol addition and crossed Kenicharo. It is a primary alcohol. So primary alcohol treated with the Jones reagent. So Jones reagent is CrO3, acetic acid and H2SO4. So in the presence of H plus, CrO3 strong oxidizing agent. Therefore primary alcohol undergo complete oxidation and gives corresponding carboxylic acid. Primary alcohol undergo complete oxidation, gives corresponding carboxylic acid. And the carboxylic acid treated with B2H6 and followed by acidification. So this carboxylic acid undergo reduction. And gives corresponding primary alcohol. Now this primary alcohol treated with the gold at 300 degrees Celsius. Primary alcohol treated with the gold at 300 degrees Celsius. So primary alcohol undergo oxidation. And form aldehyde. So here you can use copper, silver, gold. You can use any one of these reagent. And temperature nearly 300 degrees Celsius. Carboxylic acid treated with B2H6 and acetic acid. So this carboxylic acid undergo reduction. And gives corresponding primary alcohol. Now this alcohol treated with the alkene in the presence of mercuric acetate. So alkene react with the mercury. And form corresponding 3-membered ring. Now this alcohol nucleophile attack at the tertiary carbon, ring opening takes place. So it is our corresponding product. Next one is this mercury compound treated with NaBH4 and OH minus, and here it undergo free radical substitution. So simply we have to break the mercury bond. And simply we have to add hydrogen from the NaBH4. And at this carbon, hydrogen is added. And if I see this reaction, overall reaction, so this is a alkene. Now we added the corresponding alcohol. I am writing simply. So this alcohol reacted with the alkene, and the final product is like this, simply. So here the nucleophile adds to the carbon which is having less number of hydrogens. Nucleophile adds to the carbon which is having less number of hydrogens. Therefore, it is also Markovnikov product. It is a example of Markovnikov product. It is a phthalic acid. When phthalic acid treated with ammonia, so initially acid-base reaction takes place. COO minus NH4 plus. COO minus NH4 plus. But it is heated. So when it is heated, dehydration takes place and forms corresponding amide. So it is called phthalimide. Now this phthalimide, intramolecular substitution takes place, and finally it gives corresponding phthalimide. So this phthalimide treated with NaOBr. So it is a imide treated with NaOBr. So it is simply Hofmann bromide reaction. So in the Hofmann bromide reaction, if I take imide, so the final product is like this. It is a Hofmann bromide reaction. Hofmann bromide reaction. And it is also called anthranylic acid. And this amino acid treated with HNO2 and heat is given. So here NH2 group is there, and here we are having HNO2 immediately. So మన గుర్తుకు రావాల్సిన రియాక్షన్ diazotization. So in the diazotization, simply what happens, NH2 group converted to N2 plus, but we are heating, therefore denitrogen takes place. And form corresponding carbocation, and this carbocation finally converts into alcohol. So it is called salicylic acid. Benzoic acid treated with P2O5 or P4O10 and heating. So it is a dehydrating agent. Therefore, we have to do dehydration by removal of water. So here H2O is removed and finally it gives corresponding benzoic anhydride. It gives corresponding benzoic anhydride. Benzoic anhydride. Now this benzoic anhydride treated with lithium aluminum hydride. Lithium aluminum hydride, and here anhydride, here anhydride. Both anhydrides undergo reduction and form alcohol. Both undergo reduction and forms alcohol. Now this alcohol treated with MnO2, and MnO2 is oxidizing agent. MnO2 is oxidizing agent, and this alcohol undergo oxidation and forms benzaldehyde. And this MnO2 oxidizes only allylic and benzylic alcohol. It oxidizes only allylic and benzylic alcohols. Grignard reagent treated with CO2. So here pH minus is nucleophile. So nucleophilic addition takes place. Nucleophilic addition. Therefore it gives pH C double bond O, O minus. Now it is treated with H plus and corresponding benzoic acid. Now the benzoic acid treated with CH3Cl AlCl3. So this reaction is Friedel-Crafts alkylation. Friedel-Crafts alkylation. Friedel-Crafts alkylation. And we know that when benzene has meta-directing group, it do not undergo Friedel-Crafts alkylation. That means there is no reaction. There is no reaction. Ethyl benzoate. So this compound name is ethyl benzoate. Ethyl benzoate. Ethyl benzoate treated with H plus H2O heat. So it is a hydrolysis, ester hydrolysis in acidic medium. Therefore we get corresponding benzoic acid and ethanol. Benzoic acid and ethanol. And here not CaOH2, please consider bleaching powder CaOCl2. Now we are adding bleaching powder CaOCl2. So CaOCl2 means Ca plus 2 Cl minus OCl minus. When OCl minus is present, this one can be considered as Cl2 plus OH minus. Therefore here the ethanol undergo haloform reaction with Cl2OH minus. So ethanol structure is CH3 CHOH H. It is ethanol. So when we add Cl2OH minus, the CH3 part will be converted to chloroform, and this carbon part will be converted to carboxylic acid, carboxylic salt. Now it is treated with silver powder. When silver powder is added, and chloroform undergo dimerization like Wurtz reaction, Cl removed, Cl removed, Cl removed. So like Wurtz reaction, it is our final compound. Benzoic acid treated with HNO3 H2SO4. Benzoic acid treated with HNO3 H2SO4. From this mixture we get electrophile NO2 plus. Electrophile NO2 plus. And this electrophile attack at meta position because COOH is meta directing group. COOH is meta directing group. Now it is treated with FeHCl. FeHCl. Also we can use zinc HCl. Also we can use SnHCl. And we can also use H2PD. And among these three, iron is best. So here NO2 group will be reduced to corresponding NH2. NO2 group will be reduced to corresponding NH2. Now this meta-aminocarboxylic acid treated with B2H6 and acetic acid, B2H6 and acetic acid. So B2H6 and acetic acid is reducing agent combination. Therefore, the carboxylic acid undergo reduction, and it gives corresponding primary alcohol. Benzoic acid treated with Br2FeBr3. So from this we get Br plus electrophile. Therefore, electrophilic aromatic substitution takes place. Meta position Br. Now this product is treated with soda lime. So carboxylic acid in the presence of soda lime, decarboxylation takes place and acidification granted. So it is a second compound. Now it is treated with NaNH2. When it is treated with the NaNH2, so benzene connected to leaving group and NaNH2. So when benzene connected to leaving group, so we think about the first ARSN1, but ARSN1 should be possible in case of PHN2 plus. So ARSN1 not possible. Next ARSN2. So ARSN2 is possible if it is connected to minus R, and if the leaving group is S43H. If it is connected to minus R at ortho, para position or pH S43H. So in these two cases only ARSN2. And next one is benzene. If the ARSN1 and ARSN2 not possible, then benzene possible. For benzene, strong base is required. So here strong base is present. So first we have to do even CB mechanism. So in the even CB mechanism, we remove the proton and leaving group. First we remove the proton and then leaving group. Therefore, it forms corresponding benzene. Now this benzene react with the nucleophile. It is a nucleophilic addition. So nucleophilic addition takes place and corresponding stable carbanion will form. Now it undergo neutralization reaction. Finally, it gives corresponding aniline, also known as benzenamine. Benzoic acid treated with soda lime. So it undergo decarboxylation and form benzene. And benzene treated with Cl2 and AlCl3. So from this we get electrophile Cl plus. So simply here electrophilic aromatic substitution takes place. Chlorobenzene. When chlorobenzene treated with NaOH heat. So again benzene having the leaving group. So three mechanisms possible. First one, if the leaving group is N2 plus, then ARSN1. If minus R group is present or S43H group is present, then ARSN2. If both are not present, base is given, then benzene mechanism. So benzene mechanism, first step is even CB. So remove the proton. First we have to remove the proton and then leaving group. Finally, it gives corresponding benzene. Now this benzene react with the available nucleophile. So it undergo nucleophilic addition. So nucleophile attack, pi bond will be shifted. Finally, it forms corresponding product like this. Now it undergo neutralization reaction and gives corresponding phenol derivative. Phenol, also called carbinol. Phenol also known as carbinol. It is a phthalic acid. Phthalic acid. So phthalic acid treated with the methylamine. Phthalic acid treated with the methylamine. So when phthalic acid treated the methylamine, initially acid-base reaction takes place. Initially acid-base reaction takes place. So initially salt formation takes place. And corresponding salt is formed. Now the salt undergo dehydration. The salt undergo dehydration and form corresponding amide. Form corresponding amide. And which undergo nucleophilic substitution, and finally it gives corresponding cyclic compound like this. So this is the first compound. Phthalic acid, when treated with the primary amine, it gives corresponding tertiary amide. It is a tertiary amide, imide. It is also functional group imide. Now this imide treated with strong reducing agent LiAlH4. Strong reducing agent LiAlH4. And the strong reducing agent LiLH4 reduces corresponding amide group to the corresponding amine group. Amide group will be converted into amine group. Amide group converted to amine group. It is a carboxylic ester. So it is a carboxylic ester. Carboxylic acid ester H plus H2O heat. So it undergo ester hydrolysis. It undergo ester hydrolysis. So this carboxylic ester undergo hydrolysis and it gives corresponding carboxylic acid and primary alcohol. Now this mixture treated with the LiAlH4. LiLH4. So this acid undergo reduction and gives corresponding N-butanol. Of course it is N-butanol. And this N-butanol treated with the concentrated H2SO4. This N-butanol undergo dehydration in the presence of concentrated H2SO4. Since it is a primary alcohol, first it undergo dehydration through E2 mechanism. But here the problem is we are doing the reaction in acidic medium. In acidic medium, alkene again react with H plus and form stable C plus, and finally it gives corresponding stable alkene. And here trans product is major. So initially E2 only, but after that it is a alkene isomerization. After that it is alkene isomerization. Carboxylic acid treated with the PCl5. So here this carboxylic acid react with PCl5 and finally it gives corresponding carbonyl chloride. Corresponding carbonyl chloride. And this carbonyl chloride treated with the alcoholic KOH. So it is also small mistake here in the giving reagent. Because suppose according to reagent, if I follow alcoholic KOH, so OH minus attack, leaving group will leave, and corresponding carboxylic acid, and this carboxylic acid obviously do not react with the HCl. HCl the react carbon. So here the missing point is, so the exact reaction should be like this. COOH. Initially we add Cl2 and PCl3. It undergo electrophilic substitution. So this alpha carbon tautomeric proton. So tautomeric proton replaces and forms corresponding chlorine. It is an electrophilic substitution. Now we are adding alcoholic KOH. So it undergo elimination through E2 mechanism. And form corresponding alpha beta unsaturated carboxylic acid. Now it is treated with HCl and peroxide. So we know that there is no effect of peroxide on HCl. It is simply undergo electrophilic addition. So alkene react with H plus, stable C plus, and finally it react with corresponding Cl minus. So here minus R group is present, that's why we cannot write H plus C plus here. Now here if you see the alkene and product, so chlorine attached to the carbon which is having more number of hydrogens. So this is a anti-Markovnikov product. It is a anti-Markovnikov's product. It is a phthalic acid. So phthalic acid treated with the excess of alcohol in the presence of H plus. Acid plus alcohol esterification. So lone pair attack, leaving group will leave. So this is corresponding carboxylic ester. Now this carboxylic ester treated with excess 1 equivalent of dibal H. So minus 78 degrees Celsius granted. So H minus attack, leaving group will leave. So finally aldehyde is formed and the leaving group is C2H5OH. Now it is treated with H2PD, catalytic hydrogenation. It is a catalytic hydrogenation, and a catalytic hydrogenation always exothermic. So here ester group is present and aldehyde group is present, and we know that H2PD do not reduce acid, ester, amide and epoxide. H2PD do not reduce acid, ester, amide and epoxide. Therefore here ester no reduction, only aldehyde undergo reduction, and the final compound is aldehyde undergo reduction, primary alcohol is formed and ester remains as carboxylic ester. It is a phthalic acid. So phthalic acid treated with P2O5, and P2O5 is dehydrating agent. Therefore phthalic acid undergo dehydration and finally it gives corresponding phthalic anhydride. Now it is treated with ammonia and heat. So we know that ammonia react with phthalic anhydride through nucleophilic substitution and form corresponding product like this. And again undergo nucleophilic substitution, and finally the product is phthalimide. It is a structure of B, and this phthalimide treated with LiAlH4, strong reducing agent. So amide functional group will be converted into amine. Now this amine treated with NaNO2 and H2SO4 From this we get HNO2, and from this we get NO plus. NO plus is electrophile and it is a secondary imine. Therefore N lone pair attack on the electrophile. N lone pair attack on the electrophile, and finally it gives N nitrosoamine. N nitrosoamine. Cyclohexane carboxylic acid treated with red phosphorus and Cl2. It is a HVZ reaction, and HVZ is electrophilic substitution, and here it is a tautomeric proton, and this tautomeric proton replaced by chlorine. So it is a alpha chlorocarboxylic acid. Now it is treated with PCl5. So this carboxylic group react with PCl5, and finally it gives corresponding COCl, alpha chlorocarbonyl chloride. Now it is treated with H2PDBaSO4. So here we are having two functional groups, alkyl chloride and carbonyl chloride. Alkyl chloride H2PDBaSO4, no reaction, but carbonyl chloride undergo reduction, and finally it gives corresponding CHO. It is the Rosenman reduction. So Rosenman reduction is carbonyl chloride will be converted into RCHO in the presence of H2PDBaSO4. It is also called Lindlar catalyst. Therefore here COCl will be converted into aldehyde, and chlorine remains as chlorine. It is a carboxylic acid and halogen, and we are having soda lime. So whenever the soda lime is present, first according to our syllabus, first we think about the decarboxylation. So decarboxylation, so remove the CO2 and write down the corresponding anion. But here leaving group is present and resonance possible. So through resonance, leaving group will be eliminated, and finally it gives corresponding benzene. And this benzene treated with 3 moles of Cl2 and heat. So here Lewis acid is not given, heat is given. So it undergo addition reaction. It is a drastic condition. Therefore finally it gives corresponding gamaxine. Also called lindane. And also called BHC, benzene hexachloride. BHC, gamaxine and lindane. Now it is treated with alcoholic KOH. Alcoholic KOH is base. So mostly manaki alkyl chloride, alcoholic KOH always elimination, and it follow E2 mechanism. So alpha beta, remove the HCl here. Alpha beta, remove the HCl here. Alpha beta, remove the HCl here. So here the corresponding product is alpha beta. So from beta proton is eliminated. Alpha beta, from beta proton is eliminated. Alpha beta, from beta proton is eliminated. Finally we got the aromatic compound. Alkane treated with the Cr2Al2O3 10 to 20 atmosphere. So whenever you see this reaction, immediately we have to recollect our reaction. Aromatization, if minimum 6 carbons are present, aromatization, and also called reforming. Therefore here 1, 2, 3, 4, 5, 6. So minimum 6 carbon ring closing takes place, and finally it gives corresponding toluene. The toluene treated with the CrO2Cl2 and followed by hydrolysis. This entire reaction is Itard reaction. CrO2Cl2 entire organic, only one reaction is present. So here the benzylic carbon CH3 will be oxidized to benzaldehyde, benzylic carbon CH3 converted into CHO, benzaldehyde. So here the chromium complex is, so the benzylic carbon, so chromium form the complex. So this is the structure of chromium complex. So this one should be remembered. Alpha hydroxy carboxylic acid. When alpha hydroxy carboxylic acid is heated, so we should consider 2 moles of alpha hydroxy carboxylic acid. We have to consider 2 moles of alpha hydroxy carboxylic acid. So esterification takes place and forms dilactide. Esterification takes place and form dilactide. It is first compound. And this dilactide react with dibal H minus. Dibal H minus. So here nucleophilic substitution takes place for carboxylic ester and forms corresponding CH3, CHOH, CHO. So 2 moles of corresponding product is formed. Now it is treated with zinc mercury concatenate. Zinc mercury concatenate. It is a Clemmensen reduction. It is a Clemmensen reduction. So in the Clemmensen reduction, CHO group is reduced to corresponding alkane. But again the problem is here the Clemmensen reagent also contains conc and we know that alcohol and conc. So again they react and finally it gives corresponding alkyl chloride through SN1 mechanism. Through SN1. Secondary alcohol, tertiary alcohol in the presence of H plus prefers SN1. And finally we got isopropyl chloride. Alpha beta. So when alpha beta carboxylic acid, beta hydroxycarboxylic acid is heated, so it undergo dehydration. So this is a dehydrated product. Alpha beta hydroxycarboxylic acid when heated undergo dehydration. Now we are adding soda lime. So for soda lime we have to remove the CO2 and write down the corresponding carbon ion. If nothing is possible, any other thing is possible, then acidification granted. So it is a second product. Now it is treated with the Bayer's reagent. Bayer's reagent is cold alkaline camenophore. Bayer's reagent is cold alkane camenophore. So here alkene undergo oxidation and form corresponding vicinal diol. Alkene undergo oxidation and form corresponding vicinal diol. It is also called glycol. And finally camenophore will be converted into MnO2 in the presence of basic medium and it is a brown PPT. So this reaction also can be used as test for alkene. So Bayer's reagent is useful test for alkene and test for alkyne. Mainly for these two we use the Bayer's reagent. So this alkene and alkyne decolorize Bayer's reagent. Alkene and alkyne decolorize Bayer's reagent. Alpha, beta, gamma. Gamma hydroxycarboxylic acid is heated. So here intramolecular esterification takes place. So finally it gives corresponding carboxylic ester and it is called lactone. Gamma lactone. Cyclic ester manam lactone antam. Now the lactone treated with dibal H. So nucleophilic substitution takes place and finally corresponding alcohol and aldehyde is formed. alcohol and aldehyde. So here we are having alcohol and aldehyde. Now it is treated with H plus and methanol. H plus and methanol. So here aldehyde group is present and here alcohol is present and here alcohol is present. So we know that when aldehyde ketones treated with the alcohols, so we simply take the reaction like this. So here it is a intramolecular and it is a intermolecular. So first preference intramolecular. So through intramolecular it forms corresponding hemiacetal. It forms corresponding hemiacetal. Now this hemiacetal in the presence of H plus undergo SN1 reaction and react with CH3OH. So in the presence of H plus it undergo SN1 mechanism. Plus is formed because of octet. Now it react with the methanol and finally we got acetal. Finally we got acetal. So it is our final product. సో మనకి ఇక్కడ ఆల్డిహైడ్ ఉంది. ఆల్డిహైడ్కి ఆల్కహాల్ యాడ్ చేసినప్పుడు ఇంట్రా పాజిబిలిటీ ఉంది, ఇంటర్ పాజిబిలిటీ ఉంది. ఇంట్రా ఈజ్ మోర్ ఫేవరబుల్. సో మనకి హెమీ ఎసిటాల్ ఫామ్ అయింది. సో దిస్ ఈజ్ అ హెమీ ఎసిటాల్ and this hemi-acetal functional group treated with H plus and methanol, it undergo SN1 mechanism and finally forms corresponding acetal. It is a succinic acid. When succinic acid is heated, undergo dehydration and form corresponding succinic anhydride. When this succinic anhydride treated with a benzene in the presence of H plus, so it undergo electrophilic aromatic substitution and gives the corresponding product like this, electrophilic aromatic substitution. Now it is treated with a zinc mercury concave cell. Keto group will be reduced, acid cannot be reduced, therefore the product is corresponding keto reduced product like this. Now it is treated with H plus and heat. So here it loses water molecule, form carbocation, and this carbocation undergo intramolecular EAS reaction and finally forms corresponding ketone. Intramolecular EAS reaction finally forms corresponding ketone. So this reaction is Friedel-Crafts acylation and it is also Friedel-Crafts acylation. It is a 4 carbons. So if 2 carbons carboxylic acid oxalic, 3 carbons malonic, 4 carbons succinic, 5 carbons glutaric, 6 carbons adipic. So this compound name is adipic acid. When adipic acid is heated, so initially dehydration takes place and form corresponding 7-membered anhydride. And this 7-membered anhydride is unstable, so loses CO2 and form corresponding ketone. So this ketone is reacted with the KMnO4. Generally ketones do not undergo oxidation with the KMnO4, but only ketone is given and we are asking about the if ketone undergo what kind of product is formed, then definitely ketone undergo oxidation. So here we have to break the corresponding bond like this and write down COOH and COOH. It is a structure of B, you can say. Now it is heated, so it is a glutaric acid. So when glutaric acid is heated, dehydration takes place and form corresponding 6-membered anhydride. 6-membered ring anhydride, and 6-membered ring anhydride is stable. So it is our final compound. It is a glutamic, you can say glutaric anhydride. It is a glutaric N-hydride. So this ketone reaction with KMnO4, so from NCERT point of view, so it is a ketone when it is treated with the KMnO4 or K2Cr2O7. You can also use a strong oxidizing agent K2Cr2O7. Then this ketone undergo oxidation. So here we have to break the bond here. So here the statement is based on the Popov's rule. Based on the Popov's rule, this CO carbon will be attached to less number of carbon chain. Suppose this carbon is labeled CH3 COOH. So this carbon is attached to the less number of carbon chain and remaining also carboxylic acid. Alcohol treated with PCl5. So when alcohol treated with the PCl5, it is an example of SN2 reaction. Therefore here simply below the plane alkyl chloride. Now it is treated with KCN and dimethyl sulfoxide. So here Cn minus is there. It is an ambident nucleophile. So through SN2 mechanism, so we get corresponding cyanide and isocyanide because it is an ambident nucleophile. And cyanide is major. Now we are adding NaOH, H2O, heat. Therefore, cyanide undergo hydrolysis. And of course, isocyanide also undergo hydrolysis. Cyanide undergo hydrolysis and isocyanide also undergo hydrolysis. So simply here, we have to break the bond here. We have to break the bond here for hydrolysis. Carboxylic acid treated with the ethanol in the presence of H2SO4. So this is a carboxylic acid and it is also carboxylic acid, and we know that rate of esterification also depends on steric factor. That's why alcohol react with the less sterically crowded acid. Therefore, the first compound is simply carboxylic ester. Now it is treated with CH3NH2 without heat. So here it is acid and here base. So definitely acid base reaction. Heat is not given. So that's why you have to take only acid base reaction and corresponding salt is formed. Now this salt undergo dehydration on heating and form corresponding secondary amide. Now it is treated with LiAlH4, strong reducing agent LiAlH4. So here this amide undergo reduction and ester undergo reduction. When amide undergo reduction, it is a corresponding CH2NHCH3. And ester undergo reduction forms corresponding alcohol and the leaving group is alcohol. So it is a ester part reduction and it is a amide part reduction in the presence of LiAlH4. So here epoxide and carboxylic acid is given. Now it is treated with the soda lime, NaOH CaO heat. This is a soda lime. When it is treated with the soda lime, undergo decarboxylation and form corresponding anion, and of course here leaving group is epoxide is present. Finally allylic alcohol is formed. So this is the first compound. It is a allylic alcohol. Now this allylic alcohol treated with the MnO2. MnO2 oxidizes only allylic and benzylic alcohol. So here allylic alcohol is present. Now it undergo oxidation, form corresponding ketone. Now this ketone treated with the Grignard reagent, but it is a Michael compound. It is a Michael, alpha, beta, unsaturated compound, Michael compound. So Michael compound means 1,2 addition, 1,4 addition, both are possible. For Grignard reagent, 1,2 major. For Grignard reagent, 1,2 major. So 1,2 product is nucleophile attack here, 1,4 is nucleophile attack here. So 1,2 product is like this. Nucleophilic addition. It is a 1,2. And 1,4 is nucleophile attack at this benzene, at this carbon. And here minus will form and we can consider acidification. So pH minus ఇక్కడ attack అయితే ఇక్కడ minus form అయింది and minus acidification. So this is a 1,4. So 1,2, 1,4 for Grignard reagent generally 1,2 major. 1,2 major.